Yeah. And so that's kind of the idea of what we're trying to do here. And so we've got these sorts of things, these are the ranges of random numbers that you could put in. It runs 200, 300 cases, and then presents the results up here in chart form, plots, and so on. So the idea is that there's so many things that could be going on with the distribution system. There's no way to manually go in and try all of these. Let Synergi just go in and just start rolling the dice hundreds of times, thousands of times, and just generating a bunch of data so that we can hopefully find pitfalls, problem areas. And so that's what probabilistic analysis is all about. And if you haven't used it yet, give it a shot. I know that this is going to be an important application moving forward, and we're probably going to build other applications on top of this. This was another request from our training class to put protection evaluation in EA automation. So if you don't know what either of those are, the protection evaluation is going to go in and put a fault at every section and then tell you how long it takes to interrupt that fault. And so this client wanted to do that for their entire system. And whenever you need to do a study for your whole system, EA automation is the way to go. And we'll be talking about that more. But that tool is built to process, run lots of analysis over your whole system and put all the results into a database. And so this is an application we added to it. This is a brand new application from a client. This is going to go in and add generation to feeders until they hit a limit. And let's go ahead and run this thing. So you've got your feeders loaded up in Synergi. Over on the DER tab, penetration analysis is sitting here. And you've got a minimum or a maximum penetration for each feeder. And this is going to be the amount of PV generation divided by the amount of load on the feeder. What the step size needs to be. And so this will run. It'll run all of your feeders at once. So run this, and we can go in and we can check out a feeder. So I've got some issues with this one. It's probably a reporting problem with the numbers in there, but we can see the penetration levels on these things, the voltages, the exceptions, those sorts of things that show up. And so that is what this application does. And I think we put it in EA automation also. But it's we've made quite a journey with all these DER applications. And some of them we're retiring, just taking them out altogether. There's other ones we're kind of improving, and we're adding new ones. You can see the number of hosting capacity applications continues to grow. So it's a very important tab. Where are we at here? Transfer tool is on the switching side of things, and this is an application to help you evaluate how much load you can move between feeders. So what you do with this application is say, well, all right, we've got a section, a piece of our feeder here that we need to transfer, pick it up with another feeder. So you right click on a section and bring up this transfer tool right here. And what this is going to give you on the left side are the upstream switches that you can open, the current flow through these, and then over here are the pickup switches downstream. So we've got reserve values and what type of switch they are, if they're manual or automatic or whatever. So you can come in here and say, all right, we're going to open this recloser, we're going to pick it up with that, and there's a summary here of how much load we're talking about and how many customers are going. And so now what you can do then is hit this do transfer button, and it'll actually do that switching for you. And so here's the result of this. So it's a tool, that's why it's on the context menu. It's not a contingency analysis or those sorts. It's not a heavy application like that, but it's a convenient way that you can kind of evaluate your transfer options. And when you're finished, if you want, you can hit undo to go back. So that's another application that we've put in. These ones, we ran into a serious problem back early summer with fault analysis. So we've got a lot of how many of you have wandering laterals in your system? Is that, okay. Yeah, so it's, about a third of you have wandering laterals. That's where these single-phase lines come off and they run through neighborhoods and they come back and form three-phase lines and go on. It's a problem, it's difficult to run fault analysis on these because we can't just add up the impedance. So we have to calculate the impedance. That means that the fault analysis runs a lot slower. So we built a new fault analysis application that is phase domain based. And it works really well, but there were some problems with a transformer connection that we missed in testing. We screwed up. We should not have missed it, but it went out the door, and a number of you found this problem, and so we had to go back, fix the software quickly, and I think we had an update out in a day, but we eliminated that new fault analysis, so we turned it off. But we did this work because we want to have better tools to try to find these problems before they get into your hands. So what these tools are, the top one is a regression. This runs every night on our build machines. And it goes in, loads models, runs analysis, and compares results for load flow, fault reliability, I think check coordination. And it generates a whole bunch of data and then it has a comparison tool. And so when we come in the mornings, usually Neil will send me an email, say, hey, we've got a regression problem. And then we'll go and see, okay, that was because of this work, or we screwed something up, we got to go fix it. Some new work on an old system are unit tests. Now you can use all of this stuff, and we built it so that you can use it. Why would you want to use a regression? You can use that for your model build process. So if you've got models coming out of GIS and you want to see, okay, what are the differences between this model and that? You can compare databases, but I think what we're interested in is, I don't care so much if the data has changed. What I want to know is, have my results changed? Are my fault levels different? Are my voltages different? So that's what the regression could be used for. Unit tests are a little more difficult. You have to build a script. So you have to use MiddleLink to create a little circuit, tell it what analysis you want to run, and then what the results need to be. So it takes time, a couple of hours to build those things, but once they're built, Synergi can run through lots of unit tests really quickly, and you get a big pass or fail if there's a problem. So you can use these also. Then the last one is something new where we have a feature in EA Automation where you can use your models. There's a new table you can set up and put in results that you expect so that EA Automation can go through and do a kind of a QA test on your system. So this is stuff that we're doing. I hope we don't put out software that has significant bugs like that again. And it hasn't happened to us that often. Maybe every couple of years we might run into something like that where we have to do a quick fix. But we want to continue working in this area to make sure that we're doing all we can to avoid that. All right, templates here. We did some work on motors. So there's a feature in Synergi where you can have Synergi calculate the inertia values for motors. And what clients were doing is they were running locked rotor analysis, which is the instant where the voltage is applied to the motor, right? And they were running motor start and getting different results at this point. And so we did some work in there to try to make the motor start analysis more consistent with locked rotor. There are different types of analyses. There's a lot of differences in the way the models work, but by all means we should be getting the same results at the locked rotor point, and so that does happen now. Are the results the same out here? Well, we don't know because locked rotor is only looking at this point right here. It's not doing all of this stuff. So for those of you who do motor starts, it's going to be an improvement in the consistency if Synergi is calculating inertia values for you. Troubleshooting tools, let me show you this and give you a warning to don't forget to turn this setting off. Let's say I've got a load flow that takes a while to run. And maybe I've got a bunch of controllers and some stat comms and all kinds of stuff happening in Synergi, and it just takes a while. lots of iterations, and I'm not getting the results that I expect. So something's going haywire. Well, what we're adding to a lot of applications is the ability to go in, for load flow, you go into the model options, analysis tab, and you can terminate the load flow after 5 iterations. I'll go in for 2 iterations here. And now then, when I run load flow, I'm not going to see much of a difference. But what's happening here is that load flow is running 2 iterations, and then it's acting as if load flow has converged. So it's generating all these numbers. This is not a valid load flow solution, but it gives you information that you can dig into the problem. Maybe there's a transformer and a load that's way oversized. A conductor that's a data error and it's way too small. So there's problems with the model, and you can't see that when load flow runs for 100 iterations and it just kind of goes off in the boonies. So now you can stop after 2 iterations and evaluate things and try to find that data problem. So that is here. Maybe a more useful area, or an area where you're going to use this more often, is over here in load allocation. So when you're allocating loads, and this is an area where things can definitely go haywire. If the demands, the model, the consistency, if there's just issues, then load allocation might just give you results that just don't make a whole lot of sense. What you can do here is hit this troubleshooting, stop on iteration, you can put a number in there, like 10, something like that. So that way you've got a stopping point, some numbers you can look at. All right, so I think we're going all right here. So there's this guy at MIT that it's like an instructional video on public speaking on YouTube, and I think his name is Campbell. If you ever get a chance to watch him, it's a dry talk for like an hour, and he's a old school engineer type, and but he says, when's the best time to have a talk? And that's Ron's slot, 11 o'clock, right before lunch. And the worst time to have a talk is right after lunch. So so hang in there. I know the room is dark here. Recloser placement is an application you can run. And what it does, it gives you spots where you're going to get the most bang for the buck for reclosers. So it's going to multiply the exposure, the downstream conductor, where you have a potential for outages, squirrels on lines, trees, whatever it might be, and it's going to multiply that by the number of customers that are affected. So the product of the two is kind of the bang for the buck number, and then we're going to maximize that on every feeder, and that's going to be a good location mathematically. You know, this is just algorithmically for putting a recloser in. So of course, you know the system, you're the planner, you can go in and say, well, that's a terrible location, but maybe it's something where you can put a recloser nearby. So it gives you some information, a good starting point for placing reclosers.
You can set those defaults yourself. What do you want to test?
It's going to be the product. There are some settings, I think, in there. Let's look. It's over here on the reliability tab, recloser placement. Yeah, we need to put in more. So this is one of these minimum, so the exposure, the 2 things you can set. So you can use section length. If a client, if you're running reliability and you have exposure zones, you know, the exposure zones are going to be, I don't know how many folks are running reliability in here, but with exposure zones, you can come in and put in failure rates. So I've got, you know, animals, squirrels, how many failures per year do I expect from these different sorts of animals or trees or whatever. This all gets generated from your outage management system. All that data gets crunched, produces these things. And so with recloser placement, you can use these numbers instead of section length. So this would be a much better approach because these are the actual expected failure rates. And so, but a lot of times you don't have this data. So that's why section length is in there. But there's room to grow. What was that? Sure, yeah, that's a good idea. Yeah. Because it is using customer count in there. It's going to be the product of customer count for the customers who are impacted by the outage times the exposure. So it might be squaring I don't know. I wrote it down. Yep, we could. That's an important metric. Okay. All right. So these reliability settings. So these are different kind of default values to use for various types of switches, reclosers, and automatic switches and things. That's the timing. So I don't think we have any sessions on reliability analysis, but when you're running reliability, you know, we're looking for the if you're not using reliability and Synergi, you run it, and then you can come over here to the results and look at something like safety values. So this is the number of times that these customers are interrupted. So and it's a heat map, so you can look at your system and see where. So the switching, the exposure stuff that we looked at a minute ago is a big deal, right? And then how long it takes switches to operate. A crew to go out to the switch, if it's remote controlled, and that's going to be, you know, huge for SAIDI values, for example. So when you're looking at SAIDI. And so those settings in reliability are allow you to go in and do much more fine-tune your model to hopefully match the actual operation of your switches in Synergi. So we put those in. And this is a tool where you can go in. This is a client request where you can go in and you can, if you've got a whole bunch of access models, if they're on a folder, Synergi can go and collect all those up and create one giant model for you. And it can go the other way around too. If you have a giant model in Oracle or in Access, Synergi can save those out as individual databases. So this is just a maintenance tool that's pretty handy to combine and separate systems. Okay, now we've got voltage range analysis. And this application is in here to run for evaluating inverters, looking at inverters. And I'm just going to restart here because something seems a little fishy.
On that combined thing that you just talked about, what's to do with the setting ID
It's probably gonna, yeah, it's assuming that there's no conflicts. So, yeah, I mean, if there's work, I'm not sure how we can deal with, if there are duplicate IDs, I'm not sure what we can do about that, but it's probably not gonna be pretty what happens in there. Yeah. Okay, so let's look at this application here. Now, I've got a StatCom sitting down here, and I'm going to go to the build tab. I'm going to stick it up on this feeder. So let's take the StatCom and stick it up here on this feeder. And a StatCom, probably not a lot of you have modeled these in Synergi. It's pretty straightforward. It's just got you set your inverter up, and you have a size. This is a 5 MVA StatCom. I'm going to run this on one feeder here. And this application is on the Performance tab. It's brand new voltage range analysis and super simple. And we strive for simplicity. If anything, for my sake, I think the fewer settings, the more that we're kind of in control, the more that we understand the model and what's going on, the better. You know, it doesn't do anybody any good to have a gazillion settings out here because we just lose track. We don't know what's going on. So minimum voltage, maximum voltage. Do I want to lock these devices or let them operate? And this thing is just going to run every feeder from 108 to a 132. So if I do that and I turn on the report here, hit voltage range analysis, then I've got voltages here, and if I go and look at the StatCom, so I won't. If I bring up the inverter, it would mirror this. So we're running the feeder down here at 110, and then this is not labeled right. That should be VARs. So you can see the VAR. So simple case here with this StatCom, but this is a big deal for us moving forward. because now I can have all this stuff on here. I've got LTCs, I've got switch caps, I've got all these things, and I can go in and run this application. For a more serious case, now I can see, you can see the load tap changers, the effect of that. StatCom, we can look at generators. So this is a very fast way where you can take your system and run the voltage from a low value to a high value and see how these power electronics, the inverters, are dealing with that. So I know a lot of folks here are with utilities and you're dealing with these inverters in a very detailed way, and so we wanted to get this tool in place so that now we've got something that we can look at these things easier, and you don't have to do batch analysis or some other, you just hit a button now and it's good to go. Okay, where are we at here? These are blank, and we did not do work on these, but these are two applications that we want to do work on. And the non-wires alternative, what that does now is it goes in and it just looks at what we can do with, if we're going to put in some PV, if we've got voltage issues in an area, can we add PV generation to that area and just keep adding generation so that the customer's happy because they can generate and we're alleviating voltage problems. So that's the only feature of non-wires alternative right now. There's a whole world of NWA. And back when we put this in, we were geared up to do a whole bunch. We dropped the ball. We need to get back on board with this because I imagine everybody in here has something you're doing with non-wires alternatives. So we need ideas, how we can build applications that are going to save your time and let you investigate these projects. Okay, Synergi Electric 7. And two big things here, 64-bit, and we're probably, I don't see why we wouldn't have a 32-bit option. Why would we want to have 32-bit option? It's because of all the drivers. So if you're at a utility and you've got 32-bit drivers for everything, it's a headache to switch those out. So we should have Synergi Electric 7 for you, and then when you're ready to go 64-bit, you can. So here's a screenshot of what it looks like, and we are we're a good ways into this. We're striving to to make as little change as possible, and so let me run it for you live here. Oh man, I bet I don't have connection. I'll pick this up later. I messed up. I should have. I have internet for my hotel or my room, but not here. So we'll do this later in the week. When we, what's that? Really, you guys will have to see me. Let me put this on I'll come back to it. We'll see how it comes in. Yeah. So, what is the password?
It's the summary of events, exclamation point.
All right. Let's see how we go here. All right. Sun River Events. This one. Sun. Does that stay on now? Sun River Events.
Yes.
So is that right? Okay. No. Okay. Okay. So while this churns away, the big thing, two big things here with Synergi Electric 7. These symbols for these devices are all icons now. And so that means that you can go in and you can build your own. So, for the 26 years with Synergi and DPA, it's always been built in. You have to show us a picture. We would draw it, compile it, send you a library. Now, you can go in and add these icons. So, whatever symbols your utility uses, you can put those in. Of course, we'll have a set of built-in icon, or of default icons. It'll come with Synergi. But I think that'll be great for you to be able to do. You can just bring up Windows bitmap editor and just draw them in, and then you can do what you like with the icons. So let's see here. Let's give it a shot. So the feature is actually in Synergi. Now, don't do this. I'm going to do it, but it's in here, and the checkbox is right here. I think we're going to change the label to leave this checked. I've seen that in the software before. Why is it even visible here? We wanted to make sure that if for some reason something happened inside of Synergi where it flipped over to the new mapping so that you had a way to turn it off. And so just to make sure that that was available, we've got this sitting out here. So I'm going to not use the legacy map, and so we'll show the new stuff. All right. Yeah. So you don't see a lot of difference. It's got a black background. It pans. You see the way the panning works is different. I'll explain why this is different. But it's a different look, right? But you can zoom in and out. A little bit of a flash. The dragging and the dropping, the building, all that stuff works. We're working through some of these. We've got most of these tools in place. There's a few more we need to work on, and it's all about the animation. We don't want to have a lot of flicker. We want this to be responsive. We want you to get the feedback you need, and so it's a lot. Replacing a mapping system in a product like ours is a big deal, and especially when Synergi Electric went out the door in 1999. So there's a lot of stuff that has accumulated over the years that we have to rebuild here. So this is good in our minds in that it's very much like what you have now, nothing new. The benefit is the icons, but here is the big deal. And if you click this streets right here, see how this works here. Okay, so this can very much be your default, the way that the system works for you. And I've talked about this at previous user conferences, and so we've reached this goal now where you can start up Synergi Electric, your model will show up here, and you're going to have the streets and everything behind it. And I think this is one of the most important things that we can do in Synergi Electric. Fire up a phone application, if it has anything to do with space, there's going to be maps. We're just used to that. And there's so much value, so much information that we can see on this map that we're not going to see without it. Now, as a planner, you know the area. You can just look at the shape of your feeders and you have a good idea. But now you can bring this up and see it. And there's a lot of map options, a whole lot of stuff that we can explore and then we're going to make available. So ortho photos and lots and lots of data that we can access with this map stuff. So when I hit the mouse wheel, you see that? Don't like that flashing at all. But we are pulling this stuff in from the internet. Google Maps or Google Earth doesn't seem to have the flashing. I'm not sure how they do it, but we're going to continue working on this. It could be the data provider that we're using. It's an open data provider, and there's lots to choose from. So we might be able to improve that. So the flashing is quite annoying. It's pretty good here, I think. Yeah, it's looking pretty good. I mean, that's not so bad. Sometimes there'll be a delay, and you just have to wait while it draws this in. That's not good. So that's why we have this button right here, where you can just toggle it off and on. So the idea is that you get in there, you're looking at a map, and now you need to maybe move around. Maybe you need to draw, manipulate the model. Where you just hit that, very convenient. The map just goes away immediately. Now you've got much more responsive environment, and then when you want, you turn the maps back on. So this is the big deal with Synergi Electric 7.0. Once we get the mapping stuff done, well, then we'll be ready to go with this release. The reason it's different is back with Synergi Electric 6 and all the way back to 1999, the tool that we had to kind of manage the spatial data was facility based. So we would, or what they call them, some software term, but basically we have a handle on everything. So if we want to draw a transformer, we tell it where it goes, we track the handle, everything is items on the map. This system here is layer based. So there's lots and lots of layers of data, and so it's a completely different approach to mapping. So it would have been great if we could just kind of re-hook up all the stuff that we did for mapping previously, but conceptually, it's like night and day. Yes, night over there and day here between these two systems. And so that's why it's been a big deal. Now I think this approach is much more mainstream. So for some reason, if down the road we have to change mapping systems again, I think it's going to be a lot more streamlined. But it's coming along here. For you all, this is something you're going to have to do, is deal with your mapping coordinate system. So most of you, well, all of you have a projection file. And it's just a little bitty file. You can see a list of them here with a PRJ on there. You look inside of these, it's kind of terror, right? This information, now cartographers, they love this, and we've got one at the office. He retired and then he came back to work. He's just brilliant with this stuff. And so you can go into these text files and fiddle with these things and change the way the map displays. But ultimately, the maps are going to be just different ways to look at the planet and show them on a flat surface. So if you go and talk to your GIS folks, they should be able to give you a projection file for your planning area. You put that into Synergi, you go into the model settings, projection file, you select it, and then you're good to go. So yeah, you'll have to pick and choose in. And what we could do, actually the database now, if you go to the controls record, there is I think it's a WKS field where you can put that string into the model. And so we could start to load that instead, because we're ultimately using the guts of that file. And so
Maybe you have like a couple alternates, like a checkbox, if you have one more, instead of having to
yeah,
put it in the second file.
right, like a manage a list, so you can come and pick and choose. Yeah.
Just from a consultant standpoint, we're always going to have
Yeah, it's a good point. Yeah. So today it's over on the preferences where I was just at. This map right here. I'm going to turn this back onto the legacy, but this right here is a projection file. So you browse out to it. So we could have a list there, so you can go and pick. And then I think we are also going to use the database itself. So if you load a model, we can pull that well-known text, which that's a pretty cool name. We always struggle for neat names for things, and so these mapping people use WKS, or WKT, sorry, for well-known text. And